Hello everyone, my name is Rohit Singhal and we were discussing about the isomerism in hydrocarbons. So, in the previous class I have discussed about the structural isomers or structural isomer, and in structural isomer I have discussed the chain isomerism. The isomers are the compounds having the same molecular formula but different structures, and the difference in the structures lead to the difference in physical properties and chemical properties of the compounds. For example, I have discussed a few examples of I have discussed C4H10 having the two possible structures. One is N-butane, that is normal butane, 4 carbon, all the 4 carbons are present in a one straight line, there is no branching, that is why there is an substituent, there is a suffix, there is a prefix N before the name, that means a normal pentane. The other one was a substituent, a methyl group was substituted on the 2 position and corresponding to 2 methyl propane. So, these were the two possible isomers, chain isomers present possible for the molecular formula C4H10. The other I have discussed about C5H10, 1 carbon more than the butane. There are three possible structures for present having the substituents. One is methyl group and another 2 methyl groups present on the same carbon. So, till now we have discussed let us discuss one more example and we will further proceed on the alkenes isomerism. So, let us now take an example of something a functional group is present. Okay. Let us take CH3, CH2. Okay, one thing that I have told, the structures I have told till now, that it was a chain isomers we are studying, right. Chain isomers means there the substituent the substituents in the chain the substituents okay. So, let us discuss something a functional group is present. For let us take up an example of an alcohol, CH3, CH2, 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 1, 2, 3, 4. Let us take one more CH2, OH. Okay. So, what I have done here is I have replaced a CH3 proton of the last one with an OH functional group. So, till now the name what the name was pentane, right, of the normal alkane. If an alcohol is present, how will we name it? Okay, now how will we name it? When we name such kind of compounds with the presence of functional group, just remove this E present there. There is an E present, right, pentane. Remove the last letter of this E, and what do we replace by with this E is? This is an alcohol moiety, right. This is an alcohol. OH group is present, alcohol. Use the last two words. Similarly, in a normal hydrocarbons, we have used the last 3 words, last 3 letters of the name. Here we are using the last 2 words. So, what will be the name is, replace this E by OL, and also replace the position on which position the functional group is present. So, okay, on which position we can present. So, the numbering can be 1, 2, 3, 4, 5, or it can also be 1, 2, 3, 4, 5. So, what will be the naming? I have already told. So, the substituents, which one is correct? If you go by this direction, this will be the wrong one. Why? And this is the right one. Why so? This is because I have already told that the naming will be done such that the substituent on the chain is closer. So, on going from left to right, the substituent comes on 5 position. Left to right, if we are going, the alcohol is on position number 5, the OH group. And if we are going from right to left, the position of the alcohol is on the first position, that is OH. So, obviously we will prefer this one. So, how do we name this? This will remain as it is. So, it is pentane. All we have written here, on which position it is? 1. So, we will write pentane 1 ol. You can also write it's pentanol. If there is nothing written, that means substituent on position number 1. Substituent is on position 1. Okay. So, let us discuss about the isomers of this. Okay. Chain isomers possible of this. So, what are the structures? CH3, CH2, 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 1, 2, 3, 4, CH2, OH, and its name is pentane 1 ol. Okay. What can be the other structure possible? Let's change the position of this alcohol group, the OH position. It's on one position. It can be on this side or it can be on this side. Let's take on this side, so that you can better understand the numbering also. Though you should be able to distinguish the left to right or right to left numbering, but for ease, let's take it on the left side. CH2, CH2, 1, 2, 3, 4. Don't forget, please don't do this key. You change the number of carbons in the main chain. Just this should be taken care of. There should be no 1, 2, 3, 4, 5. Now what will be 1, 2, 3, 4, 5. Okay. So now what will be the structure? What will be the name of the compound? 5 carbon chain. It's still a 5 carbon chain. Okay. Still a 5 carbon chain. The position of OH group has only changed. So what we gonna name this? The alcohol group was in second position. So it will be pentane. Still is pentane. Removing E with ol, and the substituent is on 2 position. Now the other thing. Okay, so CH3, CH2, CH, OH, CH2, CH3. Now what is the what is the name? It's still a 5 carbon chain, right? 1, 2, 3, 4, 5. What if we name it from the right to left direction? 1, 2, 3, 4, 5. Same. The position is the substituent is on 3 position, and it's still a 5 carbon chain. So the name gonna be pentane. The substituent is on position number 3, 3 ol. Okay. The fourth. Now we have tried. If I will change this OH position to the here, it will again be the pentane 2 ol, which we already discussed. Then going here, it will be pentane 1 ol. So pentane 1 ol, pentane 2 ol, pentane 3 ol. These are the structures possible by changing just the position of the OH functional group. Now let's try to move carbon here and there, as we did in the previous structural isomers, previous chain isomers. Okay. So what can be the possible structure of them? Let's stick with this OH. Means the substituent is on extreme right, and change the position of the carbon. CH3, CH, CH3, CH2, CH2, OH. 1, 2, 3, 4, 5. I'm counting the number of carbons again, so I didn't miss any carbon. So it's on 1. What different ways the numbering can be possible? 1, 2, 3, 4. 1. Another possibility is 1, 2, 3, 4. Or another possibility is, or 3, 4, 4 right here or right here is the same thing. Okay. So I'm just mentioning one thing. The other thing possible is Okay, let's not use this. 1, 2, 3, 4. Okay. So what will happen in this? So this will obviously straight away this red marking will straight away be cancelled. Why is it so? Because the numbering means the substituents functional group moiety functional group is preferred while numbering the carbon chain. For example, what I am saying, in this case, if I am going in this direction, so the methyl group is coming on the second position, but the alcohol group is coming on the fourth position. So this will not be the case. The numbering will be such that the OH functional group come first. So how we can do that? That the structure will be such that that the functional group OH functional group comes first in the numbering. Okay. So means the starting will be from here, the OH functional group 1, 2, 3. Now you can name for this or for this. There's no difference. So I'm naming this. So what will be the name? So starting with the substituent methyl group is present. On which carbon it is present? It's present on 3 carbon. Methyl group is present on carbon number 3. So 3 methyl. Now how many carbon chains are there? 4. 4 means butane. But now we are going to replace this E with the with alcohol, because this is an alcohol. So we are going to replace this E by OL, and this OL will replace E. And on which position this is present? On position number 1. So butane 1 OL. So this will be the complete name of this. There are few structures more possible for this. Similarly, I have done CH3, CH2. Again, the position of methyl group I have just changed, keeping the OH functional group moiety same. The naming will be from the starting from the OH functional group, the carbon nearest to the functional group. So 1, 2, 3, 4. So its name will be 2 methyl. I have done 3 methyl. Yeah, in that case I have done 3 methyl. Yeah, 2 methyl butane 1 ol. Okay. So what other possibility? So till now I have changed the position of the CH3. Earlier I have changed the position of the OH group, then I have changed the position of the CH3 group by making the 5 possible combinations of this. Now let's try changing both the position, both moving the carbon chain, the methyl group and the OH functional group, to make more permutation combinations, whether other structure isomers can be possible or not, or we have only 5 structures possible for this. So let's try moving both the CH3 and OH group. So this is C. So what we can do, I can attach a CH3 here, right? What else I can do? I can attach an OH functional group here. One I have attached CH3, one I have attached this. So all the 3 positions are engaged by this and there will be no hydrogen in this case. So because we have to bind another carbon also. So this is CH3, C, CH2, 1, 2, 3, 4, and there will be one CH3, right? So now the 6th possibility means we are trying a moving both CH3 and OH. So we will see the substituents such that the substituent OH comes near. I have already told the functional group. So what will be name? There can be 2 possibilities. One is 1, 2, 3. The other can be 1, 2. Okay. Let's mark it with another pen. 1, 2, 3, 4. What we have in the red, that chain is of 3 carbons, and what we have in the other case, the chain is of 4 carbons. So we will prefer having a longer chain of 4 carbons and 3 carbons. Yes, there is a possible that in the shorter chain there is a functional group present on the carbon number 1, but we will have to consider that if there is a longer chain present, so we will first consider that. So, in case of whenever you name the structure, so first you see which is the longest carbon chain, then see where the functional group is closer to the where the substituents are closer. In the substituents numbering, see where the functional group is closer. So, this is the preference order we follow in naming a hydrocarbon. So, this numbering will not be followed and this will be followed. So, what will be its name? It will be 2-methyl 4-carbon, it is butane 2-ol. Remember, it is 1-ol, it was 2-ol. So, the structure there is a difference between the two structures. The other one is I have discussed in the normal pentane. Remember C5H12 formula, I have substituted both the methyl carbons on the second position. Similarly, trying this, what is structure now? This carbon number 1, 2 and 3. Okay. We can also do 1, 2, 3, but the substituent over OH will be far away. So, this will be 2 position, but there are 2 methyl groups. So, 2 dimethyl 3 carbon chain, it is propane. The OH functional group is on 1 carbon, propane 2-ol. The other possibility is 1 carbon I have done CH3, 1 carbon I have done OH, CH3. How the numbering will start? Numbering will start from this 1, 2, 3, 4. Not from this direction, as if we start from the left to right, the OH functional group will present on the carbon number 2, carbon number 3, and from left to right to left, carbon number 2 position OH functional group is there. So, this is more preferable one. So, now what will be its name? 3-methyl there will be dash in this naming. 3-methyl butane, which position OL is 2-ol. Okay. So, remember having dash here. Okay. So, these are the structures we have discussed about the possible isomers for the formula. Okay, I haven't written the formula of it here, right now. So, what will be the formula if I say there are carbon number 1, 2, 3, 4, 5, 3, 5, 7, 9, 11, 12, C5H12O. For this formula, we have 8 possible chain isomers. So, as we go on increasing the number of carbons, we can try different permutation combinations, including the O functional group, N functional group. The number of chain isomers possible will go on increasing. So, you can practice more and more questions from the NCERT or from any other book. So, for your practice to get a better hand, so you can think of which possible combinations can be possible. So, for now, thank you so much.